Christy Doyle, Executive Director at the Ontario Association of Architects. Today, we're going to learn about the TEUI Calculator. What is it and how is it used? This new tool, funded by OAA Council, was initiated by the OAA Sustainable Built Environment Committee. This is a web-based app developed to evaluate the performance of existing Part 9 and Part 3 buildings. The reason for producing such a tool is to serve a need identified by architects and licensed technologists OAA to produce an energy use intensity rating for built projects of any scale, but notably for Part 9 buildings where an energy model is often not required or performed. A need for this tool was further highlighted because of the new mandated EUI rating for submissions to the OAA's awards program. This new tool is also an important step towards achieving the OAA's goals and objectives related to climate stability. This lets users understand the current energy performance of an existing building of any size. Use of this tool is completely voluntary. The TEUI calculator is located at teui.ca for anyone to use, and today we'll also learn about the additional features that exist for our members. Using this free tool and finding out a TEUI rating is an important first step in understanding where you are. It's a benchmark. It benchmarks where you are at so you can set goals to make improvements in the future. Now, OAA Councillor Andy Thompson will discuss how to get started with the calculator. We are excited about this new tool and we invite you to try it.
While energy calculators exist all over the world, the OAA wanted to develop a tool specifically for Ontario architects that homeowners and building owners could also use. It's a simple tool that doesn't require any special training, and it's designed to be easy for anyone to use, as it's merely taking total energy use and dividing it by total gross area. TEUI stands for Total Energy Use Intensity, where intensity refers to a unit of energy used for a given unit of area. With this metric, TEUI calculation, our end result is kilowatt hours used per square meter in 1 year, written as kilowatt hours per meter over year, which has become a worldwide standard term. So let's get started and go to teui.ca. My suggestion is to use your own home or office as a test to understand how the tool works. To begin with, we have to overcome the hardest part of using this calculator, and that is locating a year's worth of your energy bills. First, gather all of your statements from the last year's hydro, electricity, natural gas, or other energy bills, plus any offsets you may pay for, such as Bullfrog Power's renewable energy credits, or RECs. Or if you do paperless bills, you can log into your customer profiles and obtain records for 12 consecutive months from there. Now that you have them, we can start to populate the fields of the calculator. What is the total conditioned area of your building? For this example, let's use a residence and we'll enter 3,000 square feet. If you enter the area of your building in square feet, you will see a conversions applied to complete the square meters field at the same time. You can also enter square meters if you prefer, and the tool will convert the square feet field. Enter any electricity used here. There are two options. You can either enter the total per year in the sum field, or you can open this drop-down menu and enter values on a month-by-month basis. The tool will add up the months for you. Let's enter 18,000 kilowatt hours per year. Now that's not great, but it's not unheard of. It's pretty standard. For a house of this size, anything lower than 1,000 kilowatt hours per month would be really efficient. Once we have all of that filled out, let's move on to natural gas. When it comes to natural gas, we're of course looking at cubic meters of gas used in the building over the course of a year. This number will be located on your bills as well. Let's put in 5,000 cubic meters annually. Now we're entering natural gas in cubic meters, but the calculator converts it into kilowatt hours because we need a common denominator for total energy. Once you've completed all of your electricity and fuel totals, you'll probably notice that the numbers are changing the EUI rating within the little house infographic. Once we've completed all the fields, we'll talk about these graphics. For now, let's jump from natural gas to propane. This field functions the same as the natural gas fields, but with a slightly different conversion factor for kilowatt hours. If you use propane, locate your bills and enter propane use in pounds per month or using the total field. Or perhaps your house doesn't use propane at all. You can skip this part and move on to section 5. If you use oil, the units are typically in liters, so you can enter the number of liters used in the same way we entered monthly amounts for totals for gas and propane. In field 6, if you use any biofuel or wood as the primary or supplemental heat, you enter in the number of cubic meters. The firewood is typically sold in cords, but one cord is equal to about 3.6 meters. So if we used 2 cords, we'd enter roughly 7 cubic meters. We have 2 sections for renewable energy contributions, both on-site and off-site. Do you have any on-site renewable contributions, such as photovoltaic panels or a wind turbine? Then you can enter your total kilowatt hours in field 7, and just like the other energy sources, there is a dropdown for summing monthly totals. Here's where the EUI number gets interesting, and we'll come back to this in a moment. But for right now, let's imagine that this home does not have any on-site renewable energy contributions, so we'll just leave that cell at 0. For the evaluation period, since my bills are for the year 2020, I'll type in January 1st, 2020 to January 1st, 2021. Just to note, the bills don't have to be from January to January. For example, they could start in July 2019 and end in July 2020. You just need to capture 365 consecutive days to derive an annual total. In field 9, you can enter off-site renewable energy or renewable energy credits. Let's come back to this. For now, we'll assume that this house does not have any off-site or on-site renewable energy sources. Now, if you're an OAA member, fields 10 through 13 are where you can enter all of your project and practice information. Now, why would we do this? Here are the potential benefits of creating an OAA TEUI report. First, it can help you understand the EUI of your home. Logging in will let you print or save your own copy of the report. Secondly, it's something you can offer your clients as a service to understand their project's TEUI after a year of occupancy. Third, it's a way of documenting or benchmarking any one of your projects or even your entire portfolio of projects. And finally, for OAA award submissions. The OAA Design Excellence Awards now requires an EUI rating on submission. This tool allows architects of smaller projects to create their own EUI report rather than needing to rely on third parties to generate reports. It is important to note that this is a backwards-looking tool to create reports post-occupancy. It is not capable of acting as a predictive tool, but you can use it to think about energy targets when designing to achieve net zero goals. The sources in the drop-down below show us how the conversion rates are used in the calculator. We've picked Canadian federal resources wherever available. Understanding your TEUI rating. The graphic of the little house highlights the TEUI rating on a scale of best performance on the one side to worst performance on the other. This scale also references some common energy efficiency standards for houses. The EUI noted is total energy from all sources divided by gross floor area in the course of 1 year. Next, we can look at the GHGI figure, which stands for greenhouse gas intensity, or carbon emissions as a function of a unit of building area or square meters. Let's remember that our national goal is to be at net zero carbon for all new buildings for 2030 and 50% more efficient for all buildings built before 2017 by the year 2050. Just to note, the goal is not to stop using energy, but to reach zero for GHGI by 2050. So in other words, we need to aim for a carbon intensity as close to zero as possible. TEUI determines your total energy use for a project, but the greenhouse gas intensity of that source of energy is what will determine your GHGI, which is the most important metric for meeting our climate targets. Let's explore some other types of buildings, such as an all-electric building versus a gas-fueled building. Or maybe instead of gas, you have an oil-fired furnace. You'll quickly see that the easiest way to lower the GHGI of any building is to reduce total energy. but even more importantly, to get this building off of high carbon energy sources. We can look at my gas line, line 3, we can see that we are heating with 51,382 kilowatt hours of gas per year. So what if we zero that out? My TEUI goes down, but we still need to heat the building with 51,382 kilowatts of energy. So we can add this 51,382 from the gas field to my 18,000 kilowatt hours in the electricity field for a total of 69,382 kilowatt hours of electricity per year. We can now see that my TEUI is still 249, but my GHGI went down to just 19.2. That's what is meant when people are talking about fuel switching. Now, if we use a heat pump, we can get the electricity down even lower. With a heat pump, we can imagine that this number could drop to 40,000 kilowatt hours total per year, which now gives us an EUI better than before, closer to Passive House and much closer to meeting our 2030 climate targets. If we improve the envelope or windows or improve air tightness, arguably all things that should precede adding a heat pump, we can get these numbers even lower. What if we found a way to add on-site renewable energy or even off-site renewable energy? Let's say we're truly aiming for a net zero energy building. We will need to offset this 30,000 kilowatt hours a year with renewable energy per year. I'll enter that into field 7. But if it's not possible to offset the kilowatt hours with on-site renewable energy, you can purchase the equivalent offsets and plug it into the field number 9, which is another way to get to zero. Renewable energy credits can be purchased from companies like Bullfrog, who build physical renewable energy capacity and put it onto our common utility grid. Purchasing these RECs can help us get our GHGI closer to zero. To learn more, you can just Google renewable energy credits. As one example, a Bullfrog residential contract for electricity will credit you with 10,200 kilowatt hours for electricity and 27,130 kilowatt hours for gas. And when you enter these numbers into field 9, they will subtract from your total electricity and gas lines, fields 2 and 3. Now look at how the GHGI number can change. This TEUI calculator is a free voluntary tool that helps us all understand the performance of our buildings using real data from energy bills and gross area. We can use the results to advertise our building's energy performance on our websites, or even as a sidebar on our drawings. And we can use it at the point of submission for building permits to further support our SB10 or SB12 energy documentation. We can also use it in conversations with clients and sub-consultants such as engineers and other stakeholders when targeting performance of buildings we are designing, based on data derived from buildings that we've completed. In order to meet climate targets, we first of all need to understand where we are in order to understand where we're going. And that's the importance of a tool like this for our membership. The TEUI calculator is a great way to understand the performance of what we have designed using standard, internationally recognized objective metrics so that we can target energy performance of the work that we have now on the boards and ultimately align our designs with our climate goals of zero carbon by 2050 and hopefully even sooner.